Hi, my name is Michael Wells. I'm a CHBP Electrical Coordinator at Bulga Open Cut in the Hunter Valley mining industry of New South Wales. I'm also enrolled in the Associate Engineering program at CQU, majoring in electrical. This presentation today has been developed to summarise my work for Semester 1 in the Engineering Associate Project Unit, where my project involved the development and construction of a remote control lawnmower. In this presentation, I will briefly be exploring the planning, design and project management techniques that we use for this project, which involved assessing the common types of retail lawnmower that were available to the market today, understanding of the problem that is involved in the use of those mowers, developing some objectives and a methodology to subsequently create a timeline for the project, and carrying on with the procurement, execution and completion of an engineering solution. It's almost common knowledge that lawn mowing and yard maintenance is often seen as a tedious and laborious task that very few people enjoy completing. And I can not personally claim that I look forward to the next time I can push a noisy, awkward and heavy, pretty much quite dangerous bit of machinery around my front yard and backyard. And whilst there's many different types of lawnmowers available today as shown on the screen, each version has its own set of issues and problems associated with the operation of it. Just like your standard push mowers are heavy, laborious and awkward to use sometimes, but riding mowers are quite expensive, often too large to use for the common consumer, and automatic mowers are quite expensive and so to begin the engineering project, it was critical to establish a strong definition of the engineering problem at hand. So for this project, it was pretty important to identify and list the issues that consumers may experience with their current lawnmower options, as previously mentioned. For the purpose of this situation, it was beneficial to identify the gap that exists in the market where remotely operated non-autonomous, non-automatic equipment could be improved and introduced. As a result of identifying that gap, I was able to develop the key deliverable outcomes of the project, which became the foundation of which a satisfactory design could be created. Just like any project in any engineering practice, this project had a tight timeline. It was to be conducted in the CQU Semester 1 calendar period. That means that deadlines and delivery dates had to be met. So as a result, it was pretty crucial to develop a set of objectives, develop a design and planning methodology, and subsequently create a timeline that identified the critical tasks and accurately forecasted work duration for these tasks. From compiling all of that information, a detailed timeline was able to be met that allowed the project to be completed in reasonable time and achieve the delivery dates. From a detailed timeline, a detailed Gantt chart, like the one shown on screen, can be developed, which becomes a key tool when the project design and execution and completion phases all begin. As mentioned, accurate task duration forecasting will determine the project's ability to meet deadlines and delivery dates due to the resultant flow-on effect that one task will have on the other, and it is the nature of this style of project methodology. For this project, like so many other projects, there was high priority placed on some of the components used in the design and execution stages of the project, such as the electric wheelchair parts that were recycled, the lawnmower that had to be purchased, pulled apart and refitted to the structure, and the steel required for the structure itself. I also had to consider some of the lead times that were of the components that were purchased online and had to be shipped into Australia. And although I completed all the work by myself with minor help, I had to allow enough time and manage my own time well enough to be allow the work to be completed on schedule. One of the positive takeaways that I also had from the execution stage of the project was the success of the original design compared to the delivered product. As you can see on the left, the design had some pretty key features that were echoed into the final design. Whilst it was not exact, I think the design process and the detail put into that worked very, very well and reflected into the final product. And one of the other successful sections of the project was the completion, testing, completion and review stages. Although it wasn't so well documented, the stage levels of commissioning of operation through the commissioning process, where we started operating on low-level stuff and operated up to full grade, maximum torque. I think that boosted the success of the overall commissioning process. On top of that, the review process is held with the stakeholders, being myself and my wife, who is 20 weeks pregnant. Really delivered some really good results and future improvements suggested for the machine. So overall, the project has been completed to a pretty satisfactory degree when compared against the project outcomes and project objectives. So at the end of the project, it's really satisfying to see a product that meets the project outcome and is a solution to the definition of the engineering problem. So as you can see here, the project has delivered a product that allows the operator to stand well away from the hazardous area of the lawnmower, which is not only a lot safer, it becomes a lot easier for someone who really hates mowing their lawn. This demonstration concludes the presentation today. I hope you have found it enlightening and informative, and I'd like to thank you for watching. Cheers.